Welcome. In this session, we will explore Azure Compute and Networking Services with a specific focus on containers. We will define what containers are, explore the primary services for running them such as Azure Container Instances and Azure Kubernetes Service, and examine how to store and network these resources effectively. To understand Azure containers, we must distinguish them from virtual machines. While virtual machines visualize the hardware, containers virtualize the operating system. This makes them incredibly lightweight. As detailed in the course material, while VMs are excellent for reducing costs compared to physical hardware, they are limited to a single operating system per VM. Containers solve this by allowing you to run multiple instances of an application on a single host machine without the overhead of a new OS for each one. This ensures consistency. The application you build on your laptop runs exactly the same way in the cloud because the code and its dependencies are bundled together. This visual comparison highlights the efficiency of containers. On the left, the VM stack requires a hypervisor and a full guest OS for every single application, creating significant overhead. On the right, the container stack shows a more streamlined approach. A single host OS and container engine support multiple containers, A and B. This shared kernel architecture demonstrates why containers are faster to start and require fewer resources than their VM counterparts. When you need to run a container immediately without architecting a complex environment, you use Azure Container Instances, or ACI. ACI is designed for simplicity and speed. It allows you to run containers on Azure without managing servers or having to learn new orchestration tools. Because it is a PaaS offering, you simply provide your container image, and Azure handles the rest. This makes ACI the perfect solution for simple applications, short-lived tasks, or automation jobs where the overhead of managing a full cluster would be inefficient. This sequence diagram illustrates the simplicity of ACI. The user initiates a request through the Azure portal. The request goes directly to the ACI service, which provisions the instance. The critical note, here is no VM config required. The system bypasses infrastructure setup entirely, returning a running container to the user in seconds. This visualizes the serverless nature of ACI. While ACI is great for single containers, enterprise workloads often require hundreds or thousands of containers working together. This is where Azure Kubernetes Service, or AKS, comes in. AKS provides a managed environment for deploying and managing container clusters. It handles the critical task of orchestration, managing the lifecycle, health, and scaling of your containers. If a container fails, AKS automatically replaces it. If traffic spikes, AKS can scale your application out. By using AKS, you offload the complex operational overhead of maintaining a Kubernetes cluster to Azure, allowing you to focus on your applications. This flowchart depicts the shared responsibility in AKS. At the top is the Azure Managed Control Plane, which Azure handles for you, providing health monitoring and scheduling. It manages the customer node pool below it. Inside that pool are the actual node VMs, virtual machines, that host your workloads, represented here as container pods. This hierarchy shows how Azure abstracts the complex management layer while you retain control over your worker nodes. For scenarios where you have a containerized web application but don't need the complexity of Kubernetes, Azure offers web apps for containers. This sits within the Azure App Service. It allows you to deploy your custom container images to a managed platform that automatically handles load balancing and auto-scaling. This option provides a balance between control and ease of use, leveraging the robust features of app service such as slots and easy authentication while using your custom container as the deployment unit. It is an ideal hosting option for standard web workloads. Before you can run a container, you need a place to store the container image. Azure Container Registry, or ACA, is your private registry in the cloud. It allows you to build, store, and manage container images and artifacts across all types of Azure deployments. It is fully compatible with the open-source Docker Registry 2.0 standard, meaning you can use the same tools you use today. Crucially, ACR integrates with Azure security features, allowing you to control who can push or pull images using Microsoft Entra ID identities. This flowchart places Azure Container Registry at the center of the workflow. On the left, a developer pushes an image to the ACR. A connection to Microsoft Entra ID ensures this action is authenticated. On the right, compute services like AKS and ACI pull those images for deployment. This demonstrates ACR's role as the central, secure repository for your container assets. Networking is the glue that holds containerized applications together. In Azure, containers can be integrated into virtual networks, VNets, allowing them to communicate securely with other resources like databases or on-premises networks. For public-facing applications, ingress resources manage external access, handling routing and SSL termination. Furthermore, for high security, you can use Azure Private Link to connect to your Azure Container Registry, ensuring that your image pools never traverse the public internet. This creates a hardened perimeter around your container infrastructure. This class diagram structures the networking relationships. The VNet class hosts the AKS cluster, providing it with a subnet. The AKS cluster connects via Private Link, which connects to the container registry. This visual hierarchy shows how networking components wrap around the compute and storage resources to provide security and connectivity. To summarize, Azure provides a comprehensive suite of container services tailored to different needs. Use Azure Container Instances, ASI, when you need speed and simplicity without infrastructure management. Choose Azure Kubernetes Service AKS when you require robust orchestration, scaling, and management for complex microservices. Opt for web apps for containers if you are lifting and shifting a web application. Finally, underpin all these services with Azure Container Registry AKA to securely store and manage your images. This final mind map categorizes the services we discussed. The root is Azure Containers. One branch focuses on compute, splitting into ACI Simple, AKS Orchestrated, and App Service, Web Focused. The other branch focuses on storage, leading to ACR for secure image management. This provides a mental map for selecting the right tool for your specific container scenario.